my channel. So in this video, we are going to prove that if given tan of x equals k tan of a minus x, then sine of 2x minus a equals k minus 1 over k plus 1 sine of a. So if you are new here, please consider subscribing and support my channel. So what is the starting point in this expression? So the idea is that it's sometimes easy to prove from the left hand side towards the right hand side, or you can always move from the right hand side towards the left hand side, but it's sometimes more obvious to work from the left hand side. So from here we can see that we need to expand this but end up with this expression on the right hand side, and you have a factor of a. And sometimes in trigonometry, especially trigonometry, we do stuff that are coming from nowhere, but as long as it doesn't change the equation, it's all about playing with functions, dividing, multiplying, and all that. For as long as you don't change the meaning of the equation, we are good. So what we have here is that we are going to say that this expression, we need to begin by introducing in this factor on this side. So I'm going to have that this is the same as sine of 2x minus a times sine of a. I'm introducing in, multiplying it here. It wasn't there, so I need to divide it, right? So this is the same as sine of a. I've not changed anything. I can cancel that and then go back to the original expression. Also that, note that we are given this part from which we can make k the subject in terms of tan, which k we are most interested in our substitution. So we have already introduced in our sine of a, it's here, but then now our target is to make sure that we compress this as possible or expand it such that we come up with k minus 1 over k plus 1. So how do we do that? We also note that when we look back, we can see that k is in terms of product of tans and also a bracket of a minus x. So we need to make sure that at least we introduce this in our expression as we work along to make sure that it's very easy for us to do the substitution. So how do we do that? I can split this angle in terms of x's and then minus a, and then also I can play some tricks on a to introduce in our x. So how do we do that? We can say that the numerator is the same as x plus x minus a, okay, or I can just try to play with the negative. How is that? We can just say that okay, so it's 2x, then I can write it as a minus brackets of a, because we already have a as a minus, but again minus x. Why do I do this? Because this bracket is what I'm most interested in. But again, you can note that if I open up the brackets, this is minus a, which you have here. Minus minus goes to positive and then becomes to x. So basically I've not changed anything. And then this is divided by sine of a. Again, I can play the same tricks right here, and then I can introduce in x and subtract of x, but again remain with a. So to do that, I'm going to say this is x, so plus, so this is a, but again take off the x. All right, so when I do this, you can see that negative x can neutralize this, okay, and then that cancels, and then it will remain with our a. And so this is multiplied by sine of a. So now what is the next step from here? The next step here is to how do we include in our tan. So the easiest way is going to be expanding this in terms of angles. Okay, so you know the formula. So this is going to give us sine of x cosine of a minus x, right? Then this is minus cosine of x, then sine of a minus x. Then this is divided by the lower term, which is again sine of x, then cosine of a minus x, but plus cosine of x, then sine of a minus x. This is multiplied by sine of a. So when we get here, now we are getting closer and closer. So the idea is that we need now to modify this in terms of tan. So how do we do that? We can see that if we divide this term up here, this will become tan, and then if we divide by cosine, this will become a tan x. So in other words, we are going to divide throughout by a function, a product of cos x, then cosine of a minus x. So because we realize that when we divide this here, this becomes tan of x, and then this will divided by here and here, it will become a tan. So let's divide throughout by this up and down. Okay, so when we do that, let's see, this is going to give us so I'm dividing throughout by sine of so we have sine of x a minus x. This is divided by cosine of x, cosine of a minus x. Then we have minus, so this is cos of x, sine of a minus x. Then we are dividing this by cosine of x, cosine of a minus x. Then the entire thing up and down, also we have down here sine of x, cosine of a minus x, then divided by the same term, cos of a minus x, then plus cos of x, sine of a minus x, then by the same term. Sometimes trigonometric proofs may seem to be intensive, but again, you just need to harden to be able to prove it. So this is that. So now all we see here is that this term can go. So let me try to change. This term can go with that. This term can go with that. This term goes with that, and then this goes with that. So what do we have? We basically now have up here that this is tan of x, then minus this is tan of a minus x, then everything over down here tan of x, then plus tan of a minus x. So this is multiplied by sine of a. Now we are getting closer. We have now tans in terms of x and all that. So now the idea is how do we make substitutions for k? So to do that, we are going to make k the subject. So I'm going to say from here, if we go back to this equation, then our equation is going to be k is equal to tan of x, then divided by tan of a minus x, right? So let's observe this equation, and then we can see that it's very clear now. We can multiply, we can divide throughout from this equation by tan of that. So if I divide this right here, this there, something is going to definitely reduce, and so we can see that from here, this is going to give us tan over tan of a minus x, then minus this is going to be 1, everything over tan x over tan of a minus x, but now plus this is going to be equal to 1. So this is what we have multiplied by sine of a. let's end this with a substitution on the left hand side, on the right hand side. And so when we have this over that, this is the same as k, and so this is going to be equal to k minus 1 over this term here is k, then plus 1, then this is multiplied by our factor, which is this, which is the sine of a. So thank you so much, guys, for watching. We can see that we have proved that sine of 2a minus x is equal to k minus 1 over k plus 1 sine of a. So if you are new here, please consider subscribing. So this is